Hello, everyone, and thank you, UXDX, for providing this opportunity to present a kind of case study that we went through at implementing, continuous delivery at scale. So the high-level agenda today is, we'll introduce something about what the problem was that we were trying to solve and why we chose, continuous delivery for that specific problem. And what the process was that we went through as a team, and then what are the outcomes and where we are heading next, right? So let me introduce myself. So my name is Haroon Rashid. I've joined recently as an engineering manager for Glovo. I'm new to Barcelona, and I'm looking forward to explore the city. For now, we haven't been able to because of the kind of COVID situation. For last few years, my focus has been around, promoting and adopting continuous delivery and engineering productivity practices in different organizations. So something about Glovo. So in terms of the organization, our vision is to create a super app that makes everything in your city accessible to you at the finger of your tips. So we have two mobile apps, one for Android and one for iOS. And we are three-sided marketplace. Obviously, we have users and customers. We have Glovers, which are kind of our couriers that deliver, that have flexibility to choose their working hours on our platforms and can work on their own schedules. We have partners, so we enable partners to connect to new and existing customers, bringing in incremental revenue to their business. And you can see, in terms of the growth that we went through in last 18 months or so, and that's phenomenal. Last year, we were opening cities at least every 4 days, we were opening up a new city. And 2 years ago, we were around operating in 3 countries and 8 cities. And now, currently, we are operating in around 22 countries and more than 300 cities. So the problem we had was around one of the key components that we had in our technology stack. And we call it Monolith. So Monolith is the backend service that kind of powers whatever we are doing at Glovo. So to give you, to make you understand, how critical this system is for us, if Monolith goes down, then Glovo stops. So you can consider, our customers cannot make orders, our couriers cannot see what they want or what the orders are they need to deliver. Our partners won't be able to receive orders and they won't be able to prepare. So imagine the situation, if something goes down around the partner side, our couriers will be on the partner restaurants, but they won't be able to get the order what the customer might have ordered, right? So these kind of situations are very critical to our business. And Monolith is a single code repository software that is shared across many different teams. So people who are developing features for couriers, for our partners, for our customers, all of them are contributing to the same code base. And the sheer volume of the code, 560K lines of code, is kind of very huge as well, right? So if something goes wrong there, we kind of lose a lot of money and revenue, and which is quite impactful when it comes to the organization, right? So the problem we had was our deployments to production for the Monolith were manual. It is until late 2019. Our deployment frequency was once per day. So imagine a scenario that as a business, you come to our engineering folks and say, okay, we want this feature to be developed, and our engineers have developed that feature, but we are not able to release because our deployment window has gone by. So the business and the development team has to wait for 24 hours for the next development window to be available so that they can release the feature. And whenever we used to deploy, the key thing was our change failure rate was around 10 to 20%. Like out of 100 deployments, 10 to 20 deployments will result in rollbacks. And rollbacks are not a good thing to have in any engineering organization, right? When you have a rollback, you have to do the root cause analysis. You have to involve people from many different teams. You need to conduct postmortems and then come up with action plans and action items for team members to make sure this kind of situation does not happen again. So there is a lot of, you can say, waste that was there in terms of our process. And it was kind of preventing us to move faster. And also, we had strict policy that we don't deploy on Fridays and weekends, because Fridays and weekends are kind of traditionally more peak time for us. And if we deploy on Fridays and weekends, we can potentially impact business, which the impact can be a lot higher. So this was the main problem that we were trying to solve at Glovo. So we decided to adopt continuous delivery practices to resolve these specific issues. Most of the things that you will see on the following slides is not something that is new to Glovo, and is not something that is very specific to Glovo as well. So what we have done is we have read about what continuous delivery is. We are taking these practices from the industry experts. There are a lot of smart people who have written books about these things, and we believe we can leverage from their experiences. So for us, continuous delivery is not just about CI/CD. And incidentally, Dave Farley, who has written a book on continuous delivery with Jez Hempel, kind of agrees with us. And this is kind of a tweet that resonates, what we are trying to do at Glovo as well. So as per Dave Farley, continuous delivery is much more than just automating your deployments. And it actually is more broader than DevOps too, in his opinion. And we tend to, agree with him. So we define, when it means continuous delivery, it's not just about automating your CI, automating your CD. Implementing a tool like Jenkins and Spinnaker is not going to say, or it is not going to represent that we have adopted continuous delivery practices. So for that, we define continuous delivery with this kind of definition. So the idea is our business can come up to us at any given point in time, and they can say they want this idea to be implemented. As an engineering team, we should make sure we should be able to develop and accept and go through this whole build, test, and deploy lifecycle as quickly as possible, maybe in an incremental way. And we should be able to ship our software whenever our business is ready, right? So our main branch should be able to release at any time. And it often requires not just the technical changes, it might require organizational change, which luckily at Glovo we are going through right now. And we are kind of there to adopt these practices. So structure is there already. Technical changes are required as well. Development cultural changes might be required. And we'll go through what kind of changes we adopted when we went through this journey. So again, the question then we asked ourselves, why do we want to adopt continuous delivery? Obviously we want to fix the problem that we had around Monolith, which is reducing time to market, and make sure our quality is not compromised when we go faster. But why do we want to do this, and what we can learn from the industry? So this is quite key for us, right? We said, we want to go faster. So we want to reduce the lead time, shorten the lead time. We want to improve the feedback loop. And we want to enable our business to experiment a lot more when it comes to new features and new features on the platform. So the idea is our business can come up with an idea. We can develop that iteratively as quickly as possible. And then we can roll it out to our customers. And our operations folks can get the feedback from our customer. And based on that feedback, they can iterate over their feature requirements. And this is quite key because without experimentation, you cannot enable your operations or your business to get the meaningful insights on a day-to-day basis within the platform. And John Elspa has this kind of famous diagram which highlights, how slow delivery cycles can impact your business as well as your development teams as compared to fast delivery cycles. So on the left-hand side, the graph shows, you have long batch sizes that are going into production. If it is not daily, it might be weekly, it might be monthly, or it might be a quarterly release. The more you delay your release, the more lines of code that you are releasing into production. And also, it will take a long time to release. At the same time, there will be a lot higher kind of chances that something will go wrong because the batch size is too big. On the other hand, if your change is small and you are kind of deploying frequently, then the chances are your code changes will not impact your system's outage, right? And your business will be happy, and in turn, your development teams will be happy as well. One of the key things for us was we looked at different surveys being done by companies, and one of the key survey that is done by Puppet Lab was quite close to what we're trying to achieve as well. So it highlights there are a number of KPIs or metrics on the left hand side, like deployment frequency, lead time for changes, mean time to recovery as well, and change failure rate. And as per them, when they floated this survey to different organizations, depending on the answer, an organization can be deemed as low IT performer, medium IT performer, or high IT performer. For us, when we answered these questions, we were around medium IT performers. So we were releasing every day. Our change failure rate was around 20 to 30%, and mean time to recover was around less than 1 day. And the motivation was that by adopting continuous delivery practices, we can move to maybe high IT performer organization where we can deploy multiple times per day. We should be able to deploy, ideally less than 1 hour, but it was not possible for Monolith, and I'll explain why. And our change failure rate should be between 0 to 15%. So to resolve that problem, the approach we adopted was to initiate a project, and the name of the project was Valkyrie. And the project Valkyrie was, we gathered, we gathered different people that were kind of contributing to Monolith. So developers from the courier side, the developers from the partner teams, and developers from the customer teams. So all these backend developers were tasked to do one thing, and there was only one objective, is to adopt continuous delivery practices for the Monolith. And what those practices are. So one of the key things was to enable continuous deployment to production on each commit. We had to change how do we manage our source code. We use GitHub as our source code repository, but the branching and merging strategy that we used to follow was Gitflow. And Gitflow, although it's a good branching strategy, but that did not enable us to have continuous deployment. So we moved to trunk-based development, which means every commit by a developer to master will go to production automatically, and there is only one source of truth for our code base, which is master. So by adopting trunk-based development, you can say, whatever is in master is in production. So there is only one source of truth. And if you want to read more about trunk-based development, there is a very good website that is managed by Paul Hammond, and he spent a lot of time in making sure all these strategies are kind of defined properly and are clear. So adoption path is very clear by following this website. Again, one of the key things for us was to define what testing means to us. Traditionally, what we have seen in the software industry and in many organizations as well, that testing is something that is a phase in the software development lifecycle. And as a developer, if you finish something, you will move your story from maybe development to testing, and someone else either in your team or a separate department in your organization will pick up that story and start testing, right? And when you do that, the risk of doing this is you go into this phase where you throw your feature over the wall to some other department or some other team member, and then you go into this cycle where they'll test something, they'll report bugs, and then you fix, and then that can go on for many iterations. And we think this is counterproductive. We think testing is a cross-functional activity that involves the whole team, and that happens throughout the project. And it starts when the project starts, but it never finishes, right? It's going on throughout the project. And this diagram, which is again from Dan Ashby, kind of highlights if you want to adopt either DevOps or continuous delivery practices, then testing is involved in each stage or each phase or each activity, whatever you want to call it, right? Planning, branching, coding, merging, building. Whenever you release, then if you are deploying, then you post-verification. Post-deployment verification is one thing that you want to test as well. When you release as well, you are testing there. Your monitoring is also kind of contributing to validation and verification activity. So all these things is testing in some form or the other, and the whole team is responsible for that. When it comes to automated deployments or releases, we adopted a tool which is open source, Spinnaker. And it's a cloud native continuous delivery tool. Netflix kind of contributed a lot to Spinnaker, and it came out of Netflix as well. In 2015, I think Google joined Netflix to develop this further. And in 2016, they open sourced this tool. And since 2016, many companies are kind of contributing to Spinnaker and are using Spinnaker as a tool for their continuous deployment workflows orchestration. So in terms of our deployment strategies, Spinnaker out of the box supports all these different types of strategies. We've gone for blue-green. In Spinnaker terms, they call it red-black. I'll just explain why we went for blue-green and how this is helping us in terms of our continuous deployment efforts. So what we do is we deploy a new cluster with the new changes. We start rolling out the traffic to the new cluster. So we do 50-50. So 50% of the traffic is going to the new cluster, while the 50% of the traffic is going to the old cluster, and we monitor. We monitor for half an hour. And then if within that half an hour, nothing goes wrong, the deployment is deemed successful, then we destroy the old cluster. Obviously, there are other strategies as well, and we are evaluating Canary deployments. And we are evaluating Canary because we think by adopting Canary analysis, we will be able to reduce the verification time window, and we will be able to do automated rollbacks. Right now, our rollback strategy is if something goes wrong, then developers can initiate a rollback using Spinnaker, which obviously we want to automate as soon as possible. One of the key things for us was, this is kind of a philosophical point more than a practice, I would say. So continuous delivery says you build the software and then you are responsible to run the software or operate the software in production as well. And we wanted to adopt this practice. But to adopt this practice, we had to develop some tooling, a lot of release process documentation, a lot of run books as well to make sure when something goes wrong, then developers know what they need to do. So run books are there to help them to understand, if this specific situation happens, what are the next steps they need to take to make sure either they can go back to a stable state or they can resolve that problem as quickly as possible. So this tweet kind of highlights, the tooling that we did and how developers are utilizing this tool. And the bot, that specific bot, we call it internally the Valkyrie police. And this basically helps our developers to send notifications when their changes are about to go live, right? So this highlights that Ray has made some changes and his feature is about to go live. And we have sent him a message on his Slack, personal message that says, okay, hey Ray, your changes are about to go live and this is the change set. And now Ray is responsible to make sure that the deployment is successful. He's kind of also responsible to make sure he's monitoring the systems when his changes have been deployed for the half an hour window that we have. And if something goes wrong, he would initiate a rollback. And all of these are then events. We are sending it to Datadog, which is our observability platform. And then we can monitor, over time, how many successful deployments we had, how many rollbacks we have initiated. And this helps us to identify, what is the change rate in terms of our deployments. So post Valkyrie, now our deployments are automated. And also we are deploying at least 8.7 times per day. Obviously, our goal was around 10 deployments per day when we started the project. But Monolith, because it's too huge, it takes a lot of time to build, test, and make sure the quality is not compromised. The deployments are fast, but the verification is still kind of manual for that change, for that half an hour window. So that's why our feature turnaround time is around 2.5 hours. But if you compare it to before, from 24 hours to 2.5 hours is a big improvement. But the key thing is our change failure rate has gone down from 10 to 20% to 1.53%. So our business is much more happier. Our platform is much more stable, and we can release with much more confidence. So whenever we release, so release now is a non-event. So previously, at Glovo, release every day used to be an event. The platform team will gather, The developer will hand over their code. We will try to deploy it manually. And if something goes wrong, the whole team will be starting to look for issues and debug issues. Now, it's a non-event. It happens automatically. The only thing developers notice is a Slack message in their Slack via the Valkyrie police that change has been rolled out. And if something goes wrong, they have the tooling available to initiate the rollback. And then we have processes in place to do postmortems and these type of things and come up with the action items if we need to improve the tooling or the process or whatever. But that's really happening right now. So that's a big win for us as an engineering organization and for Glovo in general as well. So what this has enabled us to do is to plan our next project. And this figure I've shown you before as well. I won't go into detail, but the main thing here is because Monolith is shared, so nobody kind of owns it, right? So ownership problem is there. If something goes wrong, we try to scramble people and say, okay, what went wrong? What was the change? Who's responsible? Who needs to roll back? And all these type of things. Obviously, because it's too huge, it's brittle in nature. So if you change something as a developer, you don't know what the impact is going to be on the other team or other department or the other features that we have in the app. And that's why we have come up with a lot of processes where you are making impactful changes. You need to initiate these processes, a lot of discussions. And we think that we can eliminate these type of inefficiencies in our processes. And obviously it's very complex. It's a monolith, it's a legacy system, and it's very complex to operate. It's very complex to build, test, and deploy. Right? So idea for us is we have initiated a new project, which is called the Project Darwin. It's our journey from monolith to microservices. And we believe, that having specific microservices, which are owned by different teams based on their domains, we will solve the ownership problem. Also, these will be more resilient because they are small in nature. It's easy to reason about what the change is, how we are building, testing, and deploying new changes. And also, it will help us to be more agile. So if our business comes to us with a new feature, we should be able to respond to their requests much more easily, much more quicker. At the same time, if something goes wrong in production as well, we should be able to isolate that problem to a specific microservice or set of microservices and should be able to resolve quickly. Our first microservice went live in production. And again, using the same mechanism, Spinnaker as a deployment tool, have a lot of automated testing in place. What we were able to do was we were able to have 15 deployments per day for our first microservice. Our feature turnaround time for that specific microservice went down to 0.5 hours. So if a change is ready to be deployed, we can go through the whole automated pipeline within half an hour. And that's quite a big milestone for us. So the key takeaways from the Project Valkyrie and the Project Darwin so far are, it always helps to have focused teams, which are kind of delivering a very focused objectives as well. So you need to define, whatever project you are going to initiate, if it is a technical project, what are the business KPIs and what are the kind of technical KPIs that you want to measure the success criteria, for that specific project. Then there are some key principles that we have adopted on the way. So immutable infrastructure is one of them. Immutable infrastructure means that you run some scripts and your infrastructure is there, and the source of truth for your infrastructure is those scripts. So there is no config that is done manually. There is no setting that is done manually on any of the part of your infrastructure. And the idea is you throw away your old infrastructure, you deploy a new version, you bring up new set of servers or load balancers or whatever is required to run your piece of software, and you throw away the old infrastructure. It helps you to have repeatability in your process, and repeatability and consistency is the key when something goes wrong. Obviously, when everything is successful, you don't find consistency and repeatability to be a big bonus point. But if something goes wrong, and then you can reliably reproduce that issue, then it's a big win. And we have seen this many times. If something goes wrong and you can run the same script and you get the same results, then it's a lot easier to debug and find out what the root cause is. But on the other hand, if you don't have this kind of repeatability and consistency in your infrastructure or in anything you do, especially around testing as well, then you introduce flakiness, and flakiness can contribute to loss of confidence in your infrastructure, in your practices as well. If something goes wrong, you run the same script and you get a different result, then it's very difficult to find out what the problem might be. Again, think about what kind of deployment strategies you want to adopt. We went for blue-green because we thought it's well suited for us. Now, retrospectively, it has been so Spinnaker has been in production for the last 3 months. And we think, by reducing the time, that half an hour time we have, where developer is kind of proactively looking at the logs and the monitors to make sure nothing is wrong with our production system. By adopting a canary analysis with automated rollbacks, we think we can bring in a lot more efficiency in terms of the process. We can reduce this half an hour to maybe 5 to 10 minutes. And with automation in place, what we can do is we can free up the developer. If something goes wrong, we should be able to automatically roll back and send a notification to a developer. Hey, you deployed something and we had to roll back. These are the logs. These are the issues that you need to investigate. Rather than a developer, proactively looking at, okay, I have initiated my changes. Now I need to monitor for half an hour. So automation and deployment strategies are key to make sure, you are freeing up your developer time to focus on innovation and new changes going into production, new features going into production. Operational integration is quite important. All the data that you generate from your CI/CD processes, from your testing, we are sending it to Datadog, which is our observability platform. And that in turn helps us to identify where the bottlenecks are. So again, same example, that half an hour window that we have right now has been highlighted through the Datadog integration we have, that our kind of time to market is 2.5 hours. And out of those 2.5 hours, for half an hour, we just wait. Although feature is being exercised in production, but we are just waiting. And to reduce that time, what we can do is canary analysis and automated rollbacks. Again, a lot of tooling is required to make sure developers are informed of the changes going into production. They have the documentation available. Release process is very clearly documented, especially for onboarding new people. And runbooks are there for people to understand, if something goes wrong, what they are supposed to do, right? So all of these contribute to a very healthy kind of engineering culture that we already kind of have at Glovo, but we are striving to have, improve that a lot more based on the feedback that we are getting from all these systems and all these initiatives that are going on at Glovo. Yeah. Thank you.